So like always, let's start by going to the releases page, finding the latest release, grabbing the binary from the latest release. There we go. Let's also make sure that we have the latest client version. So now got the latest client version, got the latest server version. Let's go ahead and take a look at the code here. This is the code from the last demo, if you watched it. It's a very simple class that defines a cluster. It's hosting a blockchain that's keeping track of an integer. It's a good illustrative example. It's a little bit too simple to do anything realistically useful with. So today we'll update this to use as a database and a web server that's backed by that database. So let's first start by just renaming this. And we'll say it's keeping track of a table, the schema. I have some columns to find here. Add those. Find the table schema. Let's call this movies. And we'll say primary key is a name, and then the values can be a year, and the description. That's our database. That was really simple. Let's add a web server also. Now I'll need to call the database from the web server, which means I'll need to add a fully qualified host name for it. So that's easy enough. And let's call this the web server. Now with the web server, the database is responsible for keeping track of all the data. With the web server, we don't need to focus so much on data integrity. So we can just use a sync chain here, which that doesn't keep track of any history. So that's just a tiny bit faster. And then we don't strictly need a table either. That can just be a B tree because we don't need any indexing support. So we'll call this the cache. And I guess we'll need to cache the number of views here. So that's something a client will need to look up really frequently. And then let's also add a method to synchronize these. The thing to notice with this that's I think is really cool is you don't actually have to write any error handling code to keep these synchronized because Tinychain does that all for you automatically out of the box. No code necessary. So if either of these hosts encounters an error during the transaction, even if they're running on different machines, different data centers, different applications, doesn't matter. The whole transaction across every service will automatically be rolled back. No error handling code required. So we'll use the database. Notice that I don't have to write a separate client class. I can just use the existing class. And I know that I need to insert a record into the movies table. And I'll have the key as a name, and then the value is from the metadata. Get the year and description. And we also obviously need to update the cache. So we'll add a name and a number of views is 0 because it's brand new. And let's also add a convenience method here to get the number of views. And that's the whole point of the cache. So we'll slice the cache where the name is what the caller specifies. We'll get the first record from that result set. So this will throw a not found exception if there's no movie matching the name. And then we just need the number of views. That's all of the application code we need. We'll have to update our startup script a little bit down here. We have the database started. We also got to start the web server. that running. And then we'll also, when that starts up, just for good measure, we'll add a movie. So, add movie. Add the movie Up. I think that came out in 2009. Let's see how this runs. Let's make this an executable. Schema. Now that's running. Let's check our views method and see if it works. And in fact, we do get 0 views, just as we would expect. So that is caching with Tinychain.